Hello everyone, welcome back to my another video tutorial about Go. So in this video we are going to talk about Go package management, or actually Go packages, like how you create your own packages and how you import them, and some of the inner details about how they work. Of course, I'm not gonna go into very details, just some overalls. But at the end, we're gonna understand how things work and how you can develop your own packages. So the first thing that let me see, where am I? Okay, great. So um, currently we don't have much here except for, let's go into Go packages folder that I just created. So let's go ahead and create a new file here, and then let's make some example, and let's use some existing packages for a sample, and then we're gonna create our own package. So I'm gonna use Go code for that, and it's something I like, the code editor. Of course, if it doesn't fail, which it failed for some reason. Sorry. Yeah, no, actually, it should have been working fine. I don't know. Let's try again. Okay, now it works. So here we have, let me make it bigger. So normally, like the way you use packages, right? No, not yet. So you like, first of all, you define, this is, by the way, the package main is a special package. You have to have it to create executable file, and then we have this main function, which is another special function that you have to create executable file. And for instance, if I want to use a package, I say import and then fmt. So there are a couple places where your Go installation will look at. The first one is its own directory, special directories, and the second one is it will look at your Go path and then try to find the packages that are installed on your computer. You can use go get, which is a Go tool command that allows you to download packages, third-party packages or libraries from internet, so that you can use them in your own projects, which is going to be our next video topic. But today we're just going to start off with the understanding how the packages work and how you create your own packages so that you can create a better organization, better structure for your project, in case you want to, like, let's say you want to have some n-tier or three-tier architecture, or some code reusability between other packages and so on. The packages are like one of are how the Go gives you encapsulation and abstraction. We have private symbols at package level. Like normally we have this, let's say if you're coming from C# or Java, for instance, you have private methods or private members in your class, so it is at class level. Of course, you can also do like, if you're in C#, for instance, you can do like namespace level, or you can do actually assembly level and so on, right? Here we only have this package level abstraction. So let's go ahead and continue using our package, and we say println, and then it's pretty easy. It's typical hello world, and then let's save this, and I'm just gonna go ahead and run this project, and you see we have this hello world. And now the way you do something public is you make it a capital, which we're gonna see later on in the video. But the important thing that you need to remember is that when you import a package, you use a directory path. That's important. It is not the package name you are importing. You are using the path of where your package is located, which is a directory path, right? But when you use the symbols from that path, you actually use the package name, which is fmt. It's a good practice to have your directory path and your package name as the same, which we're gonna see how they look like. So let's go ahead and create a new folder at this point, and I'm just gonna say make directory, and let's say utility. Normally don't use package names like utility, helper, and stuff like that, because they don't make much sense. I mean, you can have a lot of things on those utility things, and you make them complicated, big, and clumsy. Instead of naming them like utility, just give them a better, concise, and more cohesive names. In this example, I'm not gonna care about that, but don't do what I do here, which don't give your packages like utility or stuff like that names like that. All right, so let's go ahead and create a new. Under that, let's go ahead and say touch some stuff. Let's say strings go. Oh, sorry. Let's move this guy. Strings that go to utility, because that's how it should be. Actually, let's go into utility, and then let's create another file here, and say int. I'm just making those up, so they're not really useful names. But what I'm trying to show you is that you can have multiple files under the same package or same folder with the same package name. Mind you that you cannot have multiple packages or different package names under the same directory. So you have to have, so it's basically one package per directory. That's important. But you can have a different name, a different package name than your directory name. And we're just going to see how that looks like. So let's go ahead and open the whole folder, or whole folder with Go, say code. And you see that I have this guy. And let's actually do utility here. As I said, it is a good practice. So I can have function. I'm gonna make it public for this one. So let's say get name. Okay, I'm gonna have another name, another function here. Let's make it private. So in fact, let's do it under another file. So let's go into the strings, okay, and then have package utility, and then this time I'm gonna say get package name, and we're gonna see how that works at this moment. And this is gonna return, let's say utility, I don't care. And now I'm able to call that thing get package name. You see that because of course we need to define the return type here. So string, and that has to have a string type too. And you see that even though we have like multiple different files, Go treats them as a big big whole file, which is good, which is like classes under the same namespace. So you can just use them like that, but not exactly like classes, but whatever. So at the end of the day, all those things will be a big thing under the same package. So let's go ahead and add another one here. I'm just gonna say I don't know, I mean get my name, for instance, okay, and that returns a string, and my name is Taraguni, okay. And so I'm just gonna go into main, and the way you import packages, I mean, you can of course do this or separately, or by the way, I mean, you can see Go packages, okay, packages, and utility. Oops, utility. Oh my goodness. Of course, you have to use the package, otherwise Go tools will remove it. Go tools will remove any unused packages. So we need to say empty println, okay, and say utility, and now you can access, you can see get name and get my name and get name, even though they are from different files, but they are under the same package. And the packages in Go gives you the abstraction, as I told you before. So let's say this, and I'm just going to copy the entire thing. So I'm just going to paste it here. Oops, what happened? Yeah. Okay, so let's say get my name, okay, and then let's run this guy and see how that looks. Oops. Yeah, so many commands here. So we have this hello world, utility, and Targuni. So it is important to know that you can, as I said before, you can have a different name here. So let's say Targ package, okay? And then we'll see how that affects our stuff. We still use the same import thing, which is an absolute. There's no relative import path in Go. You have to use an absolute path, which starts from your parent directory and the other directories that you like, your package directories. And then now here you see that if I run this guy, let's see how that reacts to that change, and says, hey, there's no utility package, and that's important. Imported and not used, by the way, utility as Tariq. So it means it says you have a package named Tariq under this utility. And so if I say Tariq here, you see that I am going to be making this work. So if I run this, again, same thing. But as I said, don't do this. I mean, it's confusing, so you don't really see, what uses what unless you have an advanced editor, maybe new IntelliJ stuff or whatever. So it's recommended as a better and a best practice to do to give you a name like utility here, so that people can understand which of the imports that you're using here. Okay, so let's cover that guy. So of course there are cases where I should have applied that to this. Of course, there are cases where you may have. By the way, before I explain that, let me go ahead and do one more quick stuff. And underneath this utility, I'm going to create another folder, and I'm going to say helper, so that we can see how you name your packages. And let's say a new file, I'm gonna say myhelper.go. And when you name your package, remember to package or name it like that. So remember that you are going to use the you don't have to, but it's a good practice. You're gonna use the innermost directory name as your package name. So if I wanna, let's say, do something, get name, okay, string, oops. See, it is private, sorry, it's public because it starts with a capital G. So there's no private and public keywords. You have to use a specific naming format or cases like this. Like capital G means it's public, lowercase g means it is private, which I like. You don't have to specifically specify. You don't have to add extra keys or extra characters to define what is this private or not. So let's return something. Say helper. So when you use this guy, the way you use it is similar. Go packages. If you can type, I can't. Utility and helper. Now I can say very similar. I can say, oops, oh my goodness. Okay, now I can say helper, and that give me, of course, we need to change it, and that gives me the package, and I can easily say, oh, okay, this is coming from this guy. Of course, there are problems. Like, I mean, what if like someone else in a third-party library named their packages the way in the same name that you named your package? So let's say they named it helper. So there is a very easy way of changing that information, and you can just use alias, and I can say my helper, for instance. Oops, my helper, and now I can use the my helper to here. See, I can just simply change the package name to my helper so that I can avoid any conflict with other packages. That's how you use that. And of course, you don't have to say import all the time. You can just remove these guys, okay? And let's just use this parentheses, and it'll format this. Like Visual Studio Go runs Go tools, special Go tools, depending on the action you take. For instance, if you save it, it actually runs some tools behind the scenes and formats your stuff and removes unused imports and so on, as you saw before, and like that. So see that you can still do this without less import characters. And anyway, so you can do this. That's how the packages actually work. And the good thing is that though, when you build this guy, let's look at actually something real quick. When you run this, let's run this, okay? It actually builds the project as well, and that's fast. You see that it's real fast, just builds it. The way it works, let's go ahead and look at something more before we end this video. And I'm just gonna say city, one more. Okay, this is how, how the recommended Go Workspace look like. So you have all of your projects under source, and you have your packages under pkg, which is like third-party packages usually. Actually, there are like object files in there. You'll see what they look like. And then the bin, and the bin is where when you say go install, it actually installs, it actually builds your project and put the executable file, if there's any, into this bin directory, and you can be able to see that there. You can copy it, publish it, whatever you like it, but it's there. So let's go into pkg. All right, it's package means package, and then let's see what we have in there. See that's the architecture that I am on. It's just Darwin AMD. I'm using Mac. If you were using it Windows, it was gonna change, but nevertheless, it's still there. It's there for my case. And let's go into that. Okay, and then see. So you see that Go packages. It is the project that we're working on. Here you see this Go packages, and that's we have Go packages. And let's look into this and see how that looks like. Go packages. See that we have this utility A, and then if you look at the utility, you see like helper A and all those things. This is you see the utility A. Utility is our package we developed, right? And the helper is another package we developed. So when you do that, the way Go speeds up your compilation is that it actually creates object files. So it doesn't have to recompile everything if it's not changed. And if you look at the inside of this, so you basically like put all of your packages within this pkg folder each time you build it, and then if it's already built and there's no change in it, it's not going to build it again. So if you look at how that looks, how that object file looks, and the object files, guys, are like a pre-compiled files, and a linker at the end, a linker will link all them, link them all together into one executable file or one other file, whatever. Let's look at how it looks like. Let's say helper.a. Actually, we're in utility. You see that it didn't put your main stuff here because it's a different thing. We just put them, it puts only the packages, third-party packages and your packages, your custom packages. See, it's how it looks like. The couple things here. I mean, there's some metadata here. It gives us symbols like get name, you see that, and some other stuff. It's not really human readable, but it has some information that Go needs, not you, and it knows, it reads it and takes action based on the information here. But you see that it actually stores the symbols as well. It's like a header file or header information in. If you look at if you are coming from C#, you have this tool ILDASM, which is ILD assembler, and that allows you to look into your DLL or assemblies and see what type of information it stores. And one of the information is the tables and the tables contain or include whatever store information about your assembly, like the types or your expose, or types within that assembly, and so on and so forth. So this is similar to that. Okay, so let's get out of here. And your source is already in your source, but let's one more thing before we leave is this is a quick environment variable that I set up for myself so that I can easily access the source code directory of my Go, and then from here let's say Go packages. Okay, packages. If I can type it correctly. So here we're in Go packages, and if I say Go install, okay, I did something great, and now I can go to bin, and let's look at the Go packages that we have here. You see that Go packages, and I'm just gonna run it. And we have this hello world, utility, target, and helper. So it is an executable file. Of course, if you were in Windows, you were gonna get an executable file with an extension .exe, right? All right, so guys, that's pretty much all you need to learn. You need to know about packages and how you can use them. In our next video, we're gonna learn how we can actually use and download third-party packages from different sources. So until then, you have a great day.